Here we go. Okay. Last week we finished up logical operators and start to look at the math class or math methods. And let's review those few questions. Well, by the way, the questions or what I'm asking for actually is the Java statement or code, not just get the result. So yeah, I just give a result here, and what I'm looking for actually is something like, let's just use this one. If x is 10, that means, okay, let's do that. X is 10. And what is the result of this logical, this is the logical operators and end. This test, we want to print out the value. So that's going to be the answer, not simply just true or false. So let's get rid of those two lines, and we test the program is true. Yes, it's true. And we should include, actually, I'm going to put this whole statement here instead of just true. The next one is that. So I'm going to copy paste that in. So this is all. If either of those two is true, then result is true. So x is 10, that's greater than 5, so that's true. And of course, also less than 15. So both are true. So together, that's true. So yes, that's still true. That's good. And next one is what x is 30. So then what's the result of this operator not? I'll copy that. Same here inside this one. I give extra space and then run it. Of course, x equal to 30, that's true and not true, so it's false. The result is false. And then what about this one? So x less than 30, that's false, and not false, that should be true. Copy in and run it. Yeah, that's true. And what about greater than 50? So that's false, not false, so still true. No, it's true again. So it's true again because the quiz 4 between x and, okay, those two values, which one is the highest value, which one is the lowest. And we want to use the max method or the math method max. And of course, that's 200, but we really want to try it with a Java code. So what we need is just paste that in. Yep, so it's a fixed value, 200 and y. Oh, that's either than 1. Of course, we get the value. That's 200. But all we can do this, x is 100, y equal to 200. we will get x, y, and we should get 200 as well. Yep. And then which one is the lowest value? Because we want to try instead of max, we use the minimum as the lowest. So that should be 100. No. Yeah, I need that equal to 100. And if x is 100, what's the square root value? Huh? Yeah, the square root value. So x is 100, square root of x, and that should be 10. Yeah, it's 10, but remember the square root returns a double. So that's why I got a 10.0. So that's a 10.0. And quiz 6, number 6. If x is minus 10, what's the absolute value? So what we are looking for is a minus value. And what's the absolute value? That's ABS. That should be 10 as well. Now, since x is int minus 10, so absolute should be the positive int 10. Yeah, so that's 10. Oh, ignore the next one. The minus, that's from this line coming out. So it's 10. That's the ABS value. Okay, the last one, get a random number between 1 and 10,000. So, and what we want to do is call the random function, no parameter needed. And of course, you get if you run that, you get a double between 0 and 1. But if you want to get one between 1 and 10,000, oh, see, my answer is incorrect. It's asking for 1 and 10,000. I put 1,000 here. That's not correct. So it's 10,000. Scale up 10,000. And remember, add 1. So instead of get a 0, you get a 1. That's the minimum. Between 1 and 10,000, that include 1. And now if you add 1, that will include the 10,000 as well. So let's run it. Now you get any number. Oh, it's a double, so it still is a double, but we won't get a integer. Remember, the question is integer. So we want to int. That's not enough. If you just add an int in front, the int will convert the random to int. That's going to be 0 all the time. And then time 10,000, that's still 0 and plus 1. So you would get a 1 all the time. Let's test. So it's going to be 1, run again, still 1. So in order to get something other than 1, we want to put everything in one place and then convert the double to int. So now we should get a number much bigger. Run again. Something like that. Okay, I think we are done with the quizzes from last week. Again, if you like to watch the recording of last lesson, you can. As the link is here, so that will direct you to the video we recorded from last week. Any questions about logical operators and some math functions or methods actually. Remember, there are many math methods. You can always refer to this page and find out what are available. Since these math functions are very useful for, if you do any kind of data analysis or computation, those things or statistics, you will use one or some of them. So I recommend, or I like to try a few more. So we won't try all of them, but let's try a few more. If you need any of them, we haven't really tried, you can always just, try it yourself. Let's try a few more. So you get so we have more feel about the math functions. This time I'm going to try, let's try the power. The power of. I think that one is useful. Let's try that. So this is a POW is basically power. The X is the base, and then the Y is power. So this function or this method would return a double value of X to the power of Y. For example, let's say X is 2 to the power of 3. That's like a 3 2 times 2 times 2 again. So 3 2's time. Multiply each other, and then we would get a value of 8. So if X is 3 and Y is also 3, that means 3 times 3 times 3, that's 9, that's 27. Let's try that. So we can simply just copy this line, the few lines here, and put that into here. And so the first one is, of course, 4, 3, that's 4 times 4 times 4. So that's 16 times 4, that's 64. And if X is 4, then X to the power of 2, that's 4 times 2, 4 times 4 only, that's 16. And if the base is 10 and then power value 4, that means, you 4 tens and multiply, and that's 10 times 10 times 10 times another 10. So that's going to be 10,000. So, well, this is just small numbers. If we get a much bigger number and funny numbers, then we, cannot do that in our head anymore. We have to rely on computer. So if I put a 99 and then put something like 41, then how can I do it? So you have to rely on this, math method. And now you can see that first one, 64. Again, the POW returned double. That's why I got a 64.0. 16, and this one is not 6.6, it's 6.6, and here's a big number, and 81 zeros. So it's 6.6 and the time, then then followed by 10 to 81. That means 81 zeros after 6. So it's a huge number, right? So if I put a 10 back 0, always do something. We can do something in our head that's 10,000. Another number smaller. Okay, that's how you use the POW. It's very useful if you do math. If you write a Java program to do some math work or math project. And next one I'd like to try is sail. Is actually the sailing. like the upper limit, you know, ceiling, floor versus the ceiling. So this one means if you have a double number, you know, with decimals, the ceiling give the actually the next integer. You know, what's up? Let's say x 4.5 or 4.9 or 4.1, the next integer is 5. So that's a ceiling. And let's do that. I actually don't know the practical use of this, but there must be some cases that use it, but I just have not run into it. In need of this, you know, calling this method. Oops, something wrong, I guess, because see this, I got it wrong. I have to change it. It's not an int. We're not talking about int. I got a D here, so that's my typo. I will fix that. So we need a double. This is called programming the bugs. You may have heard of that, you know, a computer programmer, you say, oh, bug, fix that bug, this is bug, this is a bug. Bug means a little mistake. I cancel that. Now we fix it, change it from int to double. That should be fine now. You get the result, the first one. So 4.5, they say the next integer is 5. And 1 to 3 bar, oh, that's of course the next 5. And if 12, it's different from the like what we learned. Oh, if the decimal is less than half, then drop it. If it's this is not the regular rounding up. This is just get the next integer. And just like what's the next integer? It doesn't care if the decimal is smaller than 0.5 or greater than 0.5. So there's a subtle difference there. So that's a ceiling on that cell, called a cell. And in pair, you may guess that the next one is the floor. Floor basically, you know, the ceiling and the floor. Floor is the integer below this value, smaller than the value. It's called rounded down to its nearest integer. Basically, the integer smaller than this value. So for this case, you know, the integer smaller than this value is 4. And for this one, it's just the integer part. Yeah, so the floor basically is just the integer part, actually. Yeah, it's integer part. Just drop the decimal point. It doesn't, again, it doesn't care if the decimal value is greater than 0.5 or not. It just drop decimal point and the decimal digits. So that's a floor. And actually, if we do just a int conversion, that may just, it's the same effect. Let's verify that actually. What if we just use the int? Let me copy that here and run it. You should see for that, yeah. So what if we just say, remember that, just convert to int, see what happens. Okay. Int, just try to. So we should get the same, oh, of course. Interesting. It's interesting. Before I run it, so with the floor get the next value, but it's still converted to double. So we say .0. It's not really integer. It's around is the nearest integer. That's not a, you know, accurate. It's the nearest integer. I don't know, equivalent double. I don't know. It's not really integer. See, we are not seeing the integer. We still see double, but it's a double without the decimal digits, I think. But if we use the int to convert it, I think we will definitely get to integers without the decimal, point and 0 as the first decimal digits. Let's run it. And there's an error. That's because I typed too many quotes. Oh, that thing is, yeah, it did it by itself, so that's why. Oh yeah, see, that's a difference here. If we use the int to convert the double, yeah, we got the nearest integer, but then that's just integer. Then we have to, well, yeah, integer is not double. So if you use floor, it get the integer part, but it still add the decimal point back and show it as double. I think that's the only minor difference between, converting to int and using the floor method. Okay, anyway, the next one we want to try is exp. I think that's the exponential. So it's actually the power of the base is the e. And remember the e is a special little value, is constant 2 point something. The value is as a special constant. So let's try something. Yeah, I think the E is very, very special and very important in math and physics. Okay, let's run it. Yeah, so let's say if the x is 1/2, and then the exp, all that actually is the e to the power of 1/2. Then we get a value of like half of the e, and then the e at time. So that's 4 point something. And if we use x equal to 1, like this one, the e to x, that's basically the e. So the e value is 2.718. I sometimes remember the e value is 2.3, but maybe it's a long time ago. It surprised me is 1.7, 2.7. But anyway, so if the power is 0 for any remember that for any base, like no matter it's the e or 10 or 4, anything like the x to the power of 0 is always 1. So we always get a 1. Okay. And as a pair function method of exp, the next one will be the natural logarithm, or the log. This is called a natural. Remember, natural means the actually is base is e. If the base is 10, that's just that a regular regular logarithm. If the base is e, it's called a natural logarithm. So this is a reverse of the exp. Let's try a fail thing here. Yeah, that's fine. Just replace it. Okay. Let's check something. Good. On it. Yeah. So remember last time, well, in this one, we said if the x is 1/2, we get the exp value of 4.48. Now we reverse it back. So if the value is 0.482, then the log of that value should be 1.5. Of course, not exact. If you look at the result here, is like 90 very long. That's because when we do the this one, we just took the keep 3 decimal digits. I think it's right here. Yeah. So if we put the whole thing in, then we should get a closer result, closer to 1.5. But so that's close enough. And similarly, 2.718, that's not the whole thing of E. There should be more digits. That's why we, instead of exactly 1.0, we get like a 0.9 blah. That's close to 1 anyway. So again, the log of 1 is just 0. Log 1 is 0. Okay. That's the log. Both functions are very, very beautiful. Yeah. Oh, let's try a couple of other things. The cosine sine thing. There's a tangent, a tangent. Those things, yeah, these things, yeah, and I think and the log and the exp. I think if you use a scientific calculator, you have those things. Let's try cosine. And then we'll call the cosine function the value you pass to it, or the x. That's really not in degree. If you have value like a 30 degree, 45 degree, you have to do some calculation. Let's try that here. This pi here, see, you may ask, oh, what's that pi? The pi is a special variable inside this math class or math object. There's a pi, it's not a method. You see that there's no parentheses, that's not a method. When you just see that a name, that means it's a variable. And when we say it's uppercase, pi I or both uppercase, it means it's a constant variable. So the value is stored in the computer, and as is defined constant, you cannot override it. So if you try to change the value, assign a different value to this math.pi, then you would get an error, because it knows, the compiler is smart enough to know that, hey, this one is defined as constant variable double, and inside this class or object, you're not supposed to change. So you can just safely use math.pi instead of you can either type 3.14192 blah blah. You keep typing. You don't have to type. You just call the math.pi. You get the pi value. So here, I copy the value and assign it to a local variable called a little pi, pi lowercase. The Java is case sensitive, so it knows that this little pi here is different from that uppercase pi. So this is a local variable. It's only visible for those lines underneath this line. Nowhere else. So if we copy the pi value to local variable pi, then we can just call the math.cosine method and then pass this local variable to it. It will. Since this is a pi, we know that a cosine pi is -1. If we have half of the pi, that means it's 90 degrees. The cosine is 0. And of course, if we pass a 0 to cosine, then that's +1. If you haven't learned cosine, sine, cosine, you will learn but if you have, then you should know. Let's run it. So yeah, that's very close. -1, +1, 0 is not 6, is E minus 17. That means there are 17 zeros or 16 zeros. Oh yeah, I think 17. Yeah, 17 zeros in front of 6. And of course, there's a 0 and then decimal point and then 17 zeros and 6. So it's a very, very small number. So it's close to 0. Okay. Of course, if you ask, what about pi divided by 4? That means 45 degree. It's going to be a value, I think, a square root 2, square root 2. That's like 1.4, and divided by 2 again. Those should be like 0.7. 0.7, if I remember correctly. Let's verify that. Yeah, so it's 0.7. Oh, actually, you can, what if we say, if I don't know the pi value, I know a degree. Let's see, I know a degree. How about call degree equal to, how about 45 degree? No, let's say 90 degree. Okay, so it's 90 degree. It's the vertical. Normally the degree is from, if you draw a circle, the 0 degree is the horizontal axis point to right. That's 0. If you rotate, let's say, imagine there's an arrow, and from the center of the circle point to this circle, and then start to rotate the counterclockwise to up, that's 90 degree, or that's like 1/4 of a pi. So if you have a degree, then let's align them. If you want to print that thing here. You cannot do the degree here because the method expecting a reading, like the pi value, not a direct degree. If you add a 90, it can calculate, but it's calculating and give you a result you probably don't expect, because for the 90 degree cosine of 90 is 0, but instead you get a minus 0.4. So that's not correct. What you can do is you can convert. This is degree. We convert to how to use a pi. A degree divided by 180 and then time pi. Because 1 pi equals to 180 degrees, so the degree divided by 180 and then time pi is going to be the angle in reading. So now cosine of this should give us 0. Yep. Yeah, it's very close to 0. That's 0. What if we say now the 90 degree is 45? Or how about 60? 60 is an interesting number. 60 degree, I think cosine of 60. Oh, actually, I don't remember. Oh yeah, it's half. Yeah, that's what I guessed. Sine 30, the sine 30 degrees is half, or cosine 60 degree is half. So that's a half value here. Oh yeah. Sine. Sine, cosine. Yeah, there are two functions used together all the time. So we just simply change that. See what happens. Sine. let's run it. So sine pi is 1 minus 1. No, but yeah, 0, yeah, 0. The sine pi is 0. The sine 45 degree actually same as the cosine 45 degree, or false pi. Sine 0, of course, is 0. And 60 degrees, yeah, it's something like that. But if we change to 30, it's going to be half again. The 30 degrees and sine value is, yeah, close to half. Okay, I think we're done with the mass function. Let's move on to Java string. This string, remember, string is a non-primitive data type, because string, just like a mass, is a class object. So just like the mass of class, and the string has also many methods. It has many methods that can, perform some operations on strings. The first one and the most commonly used actually is the length. How to get a length of a string, because a string is nothing but a bunch of characters, surrounded by double quotes. So get the length of a string, you just call the length. First, by declare a string, now the text is a string object. Then it can access, since it's an object, remember when it's an object, just like a mass, then it can use a dot operation, object dot, and then its functions or methods. So string object txt dot length method, and give the length of the whole string. So in this case, this thing, I put like a 0 to 9, that's 10 characters, and A to Z, that's 26, and lowercase a to Z, another 26. So the total length should be 62. So if we copy that, oh, I created a thing. I called it string examples. Let's run and see if it's 62. Yeah, the length of the text string is 62. Notice that we use the plus operator here to concatenate two strings. The front is constant string, and here is a value, an integer. But when the interesting with this plus operator is that it uses a type in front of it. If the front is string, then the following is a convert to string, and then concatenate two strings together. If the front if is an integer, then the plus would, and then the second also integer, it will do the mass plus, add the two together. So that's so the plus is called overloaded operation. Another interesting method, method is called convert to uppercase to lowercase. Basically, if you have a string of mixed uppercases and lowercases, it can do, if you call up, it will convert everything to up. If you call to lower, it will convert everything to lower. In this case, if this is already lower, this part, then it just keep it lower, but it would convert that uppercase to lower. And for numbers, it doesn't do anything. So numbers still numbers. So if we try that, so we should see to upper, we should see number and all upper, and then the to lower, we should see number and then all lower. Let's run that. Yeah, that's what we see. So to upper, everything's upper. The next one, everything is lower. This is also, these two functions are also very useful when you do the when you write a program to manipulate strings or text. Let me check our time here. Okay, good. We have a few minutes left. Oh, next one is, oh, what if I want to find something in my string? You know, I want to find a character or find a bunch of character, the location, or it's called a substring, you know, a text or single character. Let's try that. Then you can call the index of, because the string is almost like it's, you know, it's multiple characters actually probably stored internally as array. So there's an index. First, it start with 0 actually. So the first one is not first. The first one is not, yeah, the first one is the first, but the first one is not, the index of the first one is not a 1, it's 0. In many programming language, you know, the index of the first thing is, you know, 0 instead of 1. That's kind of, you know, take a while to get used to it. Normally say, oh, first one is 1, right? Yeah, first one actually is 0, the index of the first one. So if you want to find 0, you get a, you know, get a value of 0 instead of 1. If you find 9, because the 9 is the tens character, you won't get a 10, you get a 9 actually. Actually, that kind of matches this sequence. Anyway, let's try that. So we want to find ABC. So ABC is here. We know that its position actually is 10 plus 26. So that the first thing A started as 27, but we want, oh, actually 10 plus 26, that's 36, right? 36 in front, and the A is at a position 37, but we should get a value 36. Remember, it's start with 0. So it's not 37, 37 minus 1, so it should be 36. If we want to find ABC, ABC is 10. Right, actually 0 to 10, ABC is 11, but it should get a value 10. And if we want to find 0, 1, 2, 3, that's the first, you know, the position is the first one. Instead of 1, we should get a 0. Let's verify that. Yeah, 36, 10, 1. You say, what if I want to find Z? Uppercase Z, not lowercase, uppercase Z. We know the Z is at position 36, but instead of 36, we should get a 35. Yep, Z is a 35. How about lowercase c? Lowercase c, that's 37, 38. 39 minus 1, so 38. Should get a 38. Yeah, we get a 38. Yeah, so that's the index of. Oh, I'll be running out of time. Yeah, we can finish the rest next time. It's already 47. Yep, let's finish this next time, but it's okay. Again, I think I listed a few quizzes. Yeah, I don't think you can do the last one. So you can do everything but the last one. All right, I'm going to stop sharing. And yeah, that should be it. And I'll see you next Friday. Have a good evening.